Alright, so I would like to talk about terminology of integration here for a minute and talk about what some of these things mean. So we know there are two types of integrals, and if you haven't seen my video on integrals, definite versus indefinite, and you're still a bit shaky on that, that might be a good idea, but I will do a quick recap within this video. So here we go. Two types of integrals basically. We have the definite integral and then we have the indefinite integral. The indefinite integral is exactly the same thing as the antiderivative, and the definite integral is going to give us some function of area. So a quick illustration of what this means. Over here for an indefinite integral, and let's just give ourselves a little extra room here to do an aside. Alright, so an indefinite integral or an antiderivative is saying what function, when I take its derivative, gives me this, gives me f of x. So if f of x is 2x, I'm saying what is it when I take its prime that gives me 2x? Well, x squared, if I take the prime of x squared, I'm just going to pull this 2 down and I'm going to get 2x as the prime. So the antiderivative of the indefinite integral of 2x is just x squared because it's the prime. The prime of x squared is 2x. So that's a really easy, familiar example for what the indefinite integral is. And to talk really quickly about the definite integral is different. The definite integral has an a and a b, and we'll talk about what this means in a minute, but it just is saying I've got this function, some function, and here's my graph, and on my graph I've got f of x. F of x is doing its little thing here. And I've got some points on this function, a and b. We'll say they're here and here. And so I'm going to draw lines up from this point until they smash into the function. Okay? And the integral, the definite integral, allows us to figure out how much space is right in here with a zero degree of error, there's no error, there's no factor of error there whatsoever. We can tell perfectly how much is inside this part of the function until we hit the x-axis. So this is the definite integral. The definite integral takes functions and it spits out area. Now, sometimes it spits out area like a number, and sometimes it spits out functions that allow us to compute the area, and we'll talk about that in a fundamental theorem of calculus video. So, sometimes we will get an f of area that allows us to just go and plug, we get a new function that now that we've taken the definite integral, we've arrived at this function, and we can just start plugging in any point we want and not have to integrate anymore in order to find out area over different intervals, a to b, a to c, a to d, a to whatever. So this is the definite integral. Great. So let's talk about the terminology here now that we've gone over what these are in the basics. So let's talk about the antiderivative first. Let's talk about the indefinite integral first. You notice that this just is the integral from a to b of f of x dx. That's all this says over on definite integral. But on the indefinite integral, we have this f over here. F equals the integral f of x dx. So this f, all this stands for, this just means antiderivative. So, that's antiderivative, that's what this f stands for. So we've taken care of f. Equals is pretty obvious. It equals this. It equals all of this right here. This entire thing is the integral. Over here, of course, this entire thing is also just the integral. So we've taken care of that. Now let's talk for a second about things within this integral. So we've got this sign right here. What does this mean? Well, this is just telling you integrate whatever I've got next to it. So this is telling you to integrate its function, but what do we call this function? Well, in both of these, this is the integral. This is the same between definite and indefinite. It doesn't matter. And so these are integrate this, and this, the thing it's talking about, this is the integrand. All right, and this right here, dx. Now, of course, you should know that this could also be dy or dt or d theta or d anything. It is just telling us what variable we need to integrate with respect to. So this is the variable of integration. Alright, so we have our variable of integration, we have our integrand, we have the integral symbol, the integrate symbol, we have the entire thing, which is the integral. Now we have these little guys right here, a and b. This is the interval of integration, and a and b are your upper and lower bounds. Now this is getting a little bit messy, so I think what I'm going to do is I'm going to go ahead and erase all of this and then rewrite one new giant indefinite integral and label everything again so that it can be really concise what we're talking about. Now a quick note here on how this looks. You should immediately be raising your eyebrows saying, wait, what do you mean the antiderivative over an interval? This doesn't work. You're absolutely right, it doesn't work. This is a hypothetical integral that can't really exist, that just exists to show you an indefinite and a definite together so that we can talk about the terminology of what each piece means. This is not a real integral at all. Of course it's not, because you can't have the antiderivative over a domain like this. I know it doesn't work. This is just to explain terminology and understand the concepts. So that's why I've written this f equals really big. So we're going to go ahead and recognize that this is just the antiderivative. That's what this is saying. So, great. That's the antiderivative. What's this thing right here? This symbol, if we remember correctly, we'd probably use a different color, shouldn't we? This guy right here, this is just instructions to integrate. When you see this, it's just saying integrate this. Within here, we have two separate things. We've got this f of x, and we've got this dx. This f of x, this is the integrand, or the thing you're integrating. And then we've got this dx over here. This dx is just the variable of integration. All right, and now what do we have left? Well, we have these guys left right here. A and B. These are the limits of integration, or the interval over which we're integrating. This guy right here on the top and this guy right here on the bottom have different names, only slightly, and I promise you they're not confusing. On the bottom, this is our lower limit of integration. And on the top, you can probably guess, this is our upper limit of integration. So, that is all the terminology, the basic terminology, that needs to be understood for integral calculus going into looking at some problems.